Okay, so for this lecture, we're going to actually now go through the decision-making uh, steps that we talked about in the last lecture. Okay, so the decision-making process can actually be calculated in Excel. And when I post the assignment, I'm also going to post a template, an Excel template that you can use to make calculating everything a lot easier. It can also be done by hand. And just another note that numbers in parentheses are just negative numbers. So if you see a number in parentheses, it just means that the number is a negative number. So let's go through this scenario and see if we can figure out what the best option for this person, or what the best decision for this person is in this scenario. So we have James, who's returning for his junior year of college and would really like to get an apartment off campus. But can he afford it? He's also not sure how often he really wants to cook for himself, and he's worried he might eat out at restaurants so much that it will be expensive. So he begins pricing apartments around town and talking to potential roommates to see if it might work out. The time frame for his decision is 1 year. So we have two different actions. We have action A, which is to live on campus, and action B, which is to rent an apartment off campus. And then we have 4 different outcomes. And with those outcomes, James has assigned different probabilities. We then have our objective and subjective utility, and then we'll calculate our net utility. Okay. So the next slide will actually now describe the outcome. Okay, so James has 2 action options. 1 is to live on campus, and 2 is to rent an apartment off campus. So let's go through the actions and the outcomes of each option. So action A is to live on campus. Outcome 1 is James gets a really great dorm. It's convenient and quiet so that he's able to study. He feels that meals through the campus food service are good and reasonably priced. Outcome 2 is James gets a very noisy dorm. He is far away from the classroom where most of his classes are, and he had a hard time studying and has to go to the library most evenings. He feels the meals, though through the campus food services, are so-so and a little expensive for the quality. Then action B is to rent an apartment off campus. So outcome 3 is expenses work out well. He ends up with some really great roommates, one who really loves to cook and has a short walk to campus. Outcome 2 is expenses end up higher than he anticipated. Cooking meals is a hassle. His roommates are noisy and don't understand why he's always studying. James misses the convenience of being on campus. Okay, so now we're going to take a look at the probabilities. So outcome 1 has a 30% probability that if he chooses to live on campus, he will have a great dorm. Outcome 2 has a 70% probability that if he chooses to live on campus, he'll be placed in a very crappy dorm. Outcome 3 has an 80% chance that if he chooses to live off campus, he will have a great convenient apartment. And outcome 4 has a 20% chance that if he chooses to live off campus, he will have a horrible, inconvenient apartment with terrible roommates. Next, we assess the subjective and objective utility of the outcomes. So outcome 1, we have a $7,000 objective cost, meaning we will have an actual expense of $7,000. We have a $500 subjective benefit, meaning if we stay on campus and have a great dorm, this is worth $500 worth of satisfaction. Outcome 2 has an objective cost of $7,000 and another subjective cost of $1,000 if the dorm is horrible. Outcome 3 has an objective cost of $6,500 and a subjective benefit of $650 if he lives off campus but finds a great apartment. And outcome 4 has an objective cost of $7,200 and a subjective cost of $2,000 if he moves off campus and gets a horrible apartment with horrible roommates. Now we will look at the net utility. Remember, this is done by summing the objective and subjective utilities. So for outcome 1, the net utility is negative 7,000 plus 500, which gives us negative 6,500. For outcome 2, the net utility is negative 7,000 minus 1,000, which gives us a net utility of negative $8,000. Outcome 3, the net utility is negative 6,500 plus 650. This gives us the net utility of negative 5,850. And for outcome 4, the net utility is negative 7,200 minus 2,000, which gives us a net utility of negative 9,200. So we're going to use this information that we calculated to answer for each rule that we learned about. Okay, so the first rule is the maxi-max rule, where we look at the outcomes with the highest net utility. So for action A, this would be outcome 1 with a net utility of negative 6,500. For action B, the best outcome is outcome 3 with a net utility of negative 5,800. Based on this analysis, we would choose action B because it has the highest net utility. But what's the problem with this analysis? Remember, with maxi-max, it does not consider probability. So although in this case, option 3 has the highest probability, it could also have easily the lowest. And even option 1 has a lower probability than option 2 for action A. So next, we'll look at the best of most probable rule, where we pick the option with the highest probability. So we would choose outcome 2 under action A because the probability of this occurring is 70%. For action B, we would choose outcome 3 again because its probability is 80%. We then choose which of the two has the highest utility. For this, it is again action B. Now we move on to the minimax rule, which we choose the outcome with the lowest utility. For action A, it's outcome 2. This has the lowest utility. For action B, it's outcome 4. That one has the lowest net utility. We then choose which of the two has the highest utility. So for this one, it's action A. Finally, we look at the highest expected value, which again involves some math. We multiply the probabilities with the net utility and select the action with the highest utility. So for action A, the formula for that is 0.30 times negative 6,500 plus 0.70 times negative 8,000. And that gives us a net utility of negative 75,550. We do the same for action B. So the formula for that is 0.8 times negative 5,850 plus 0.2 times negative 9,200. And that gives us a net utility of negative 6,500. We see that the option to live off campus has the highest expected value. So we choose action B. All right, so that concludes the demonstration of how to go through the decision-making processes. I know that it can be a little confusing, so please feel free to send me an email if you have any questions or comments, or if you want to go through this again, detail by detail. All right, bye.